In this episode, we move from the general idea of responsible system design into the specific design choices that make an artificial intelligence, AI, system governable once real people start using it. New learners often imagine that oversight and control happen after a system is built, as if a team can finish the model, release the interface, and then add supervision later through policy memos or extra meetings. In practice, the opposite is usually true. If human oversight, meaningful metrics, usable thresholds, strong feedback paths, and practical controls are not built into the design from the beginning, the organization will struggle to manage the system once it is live. The result is often a workflow where people trust outputs too quickly, warning signs are missed, and the team cannot tell whether the system is improving work or quietly making it less reliable. Strong governance begins when the design itself creates room for people to question the system, measure what matters, slow things down when necessary, learn from experience, and correct behavior before small weaknesses become serious failures. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. One of the easiest mistakes to make in AI design is assuming that a technically capable system will naturally fit into a controlled human process. That rarely happens on its own. When organizations focus only on model output quality and ignore the surrounding workflow, users often receive results without enough context, supervisors lack visibility into how the outputs are being used, and the system begins to shape decisions more powerfully than anyone intended. This is why oversight, metrics, thresholds, feedback, and controls are not separate extras. They are parts of the operating environment that determine whether the system remains useful and trustworthy after launch. If the team waits to add them later, the interface may already encourage over-reliance. The logging may already be too weak. The escalation path may already be unclear, and the habits of daily use may already be moving faster than the governance structure. Designing with these elements from the start is not about slowing innovation. It is about ensuring that the system can be used with clarity, restraint, and accountability when the pressure of real work begins. Human oversight is the first of these design elements, and it means much more than placing a person somewhere near the system. Real oversight depends on whether a human being can understand what the system is doing well enough to notice trouble, interpret outputs in context, and intervene with meaningful authority when the result looks unsafe, unreliable, or inappropriate. A poorly designed system may claim to keep a human in the loop while giving that person only seconds to review outputs, little explanation of uncertainty, and no practical way to challenge or reverse a recommendation. That is not meaningful oversight. It is decorative oversight, and decorative oversight fails quickly when systems are used at scale. A well-designed system instead makes the human role visible and workable. It gives the reviewer enough context to understand the case, enough time to exercise judgment, enough clarity to see when the output should not be trusted, and enough organizational authority to stop, escalate, or override the system when the situation calls for it. That design challenge becomes much easier when the organization defines the oversight role explicitly rather than treating it as a vague expectation. Someone needs to know when they are reviewing the system what kinds of cases deserve closer attention, what signs of poor system behavior matter most, and what actions they are authorized to take when those signs appear. A reviewer who is told to be responsible without being told how responsibility works is often forced into making improvised decisions under time pressure, and that kind of improvisation creates inconsistency and weak accountability. Good design, therefore, includes clear review points, clear decision rights, and clear distinctions between routine cases and cases that must be escalated. It also includes training and practical guidance, because even a thoughtful interface cannot solve the problem of an unprepared reviewer who does not understand the system's limits. When oversight is designed well, the human role is not just to approve outputs. It is to bring context, judgment, and caution into places where the model alone should never have the last word. The design of the user experience also matters greatly for oversight, because people respond not only to what the system says, but to how the system presents itself. A system that always sounds confident, never surfaces uncertainty, and never reminds the user of its limits can quietly train people to trust it more than they should. A system that hides source context or makes it difficult to compare input with output can make weak recommendations look smoother and stronger than they really are. Good design resists that kind of false authority. It can present relevant context, show when the system is uncertain, make it easy to review the information that shaped the output, and create visible moments where users must choose whether to accept, reject, or escalate a result. The goal is not to make the interface frightening or slow for no reason. The goal is to make the reality of judgment visible. When the design supports careful use, human oversight becomes more than a policy requirement. It becomes a normal and practical part of everyday interaction with the system. Metrics are the next major design element, and many beginners misunderstand them because they assume metrics are only about model accuracy. Accuracy matters, but it is only part of the picture. A system can achieve strong overall performance and still create serious governance problems if it performs poorly on the hardest cases, if it behaves inconsistently across different groups, if users misunderstand its output, or if it encourages staff to act too quickly because the workflow rewards speed over judgment. Good design therefore begins by asking what should actually be measured in the real operating environment. The answer may include quality, consistency, error rates in sensitive situations, override frequency, user reliance patterns, escalation volume, time to review difficult cases, or the rate at which feedback reveals missing context or weak assumptions. Metrics become meaningful only when they reflect the real purpose of the system and the real harms the organization is trying to avoid. Otherwise, teams may report attractive numbers while missing the signs that matter most. A mature design also distinguishes between metrics that describe what happened and metrics that help predict what may be going wrong. Some measurements show the results after the fact, such as the number of incorrect outcomes discovered in later review or the number of complaints received from affected users. Other measurements give earlier warning, such as a rising rate of human overrides, unusual shifts in confidence patterns, sudden changes in the type of inputs being processed, or a growing tendency for users to accept outputs without meaningful review. Both kinds of measurement matter. The first helps the organization understand impact once the system has been used. The second helps the organization notice drift, over-reliance, or hidden instability before the effects become larger and harder to reverse. Designing for measurement, therefore, means deciding early what signals will be collected, how they will be interpreted, who will review them, and what level of change will trigger investigation. A system without those decisions in place may still produce outputs, but it will be much harder to govern because the organization will be flying with too little visibility. Thresholds turn those measurements into action, and this is where design becomes especially practical. A threshold is a decision point that tells the system or the people around it when something should happen differently. That might mean a score below a certain level triggers human review. A confidence pattern outside expected bounds pauses automated handling. A sudden rise in overrides leads to deeper evaluation, or a sensitive case type is never allowed to pass through the system without additional scrutiny. Thresholds matter because they prevent teams from drifting into vague judgment about whether the system feels acceptable. Good governance requires clearer triggers than that. If there is no agreed point at which escalation begins, then everyone is left to improvise, and people under pressure often postpone difficult decisions until after a problem has already grown. A well-designed threshold does not eliminate human judgment. It supports human judgment by making it easier to know when a case should slow down, when a pattern deserves investigation, and when the system should no longer be treated as routine. Feedback is another element that must be designed rather than assumed, because organizations often say they want continuous improvement without building any reliable path for learning. Real feedback can come from many places. Users who reject outputs, reviewers who notice recurring weaknesses, supervisors who see troubling patterns in the workflow, affected individuals who complain about poor outcomes, or later investigations that reveal the system was making the same kind of mistake repeatedly. If the design does not capture those signals in a usable way, the organization loses a critical source of governance intelligence. A thoughtful system makes it easy for users to mark an output as unhelpful, unsafe, incomplete, or inappropriate, and it gives reviewers a way to explain why they overrode the system rather than merely recording that they did so. Over time, these signals help the organization see whether the problem lies in data quality, workflow design, missing context, poor threshold selection, user misunderstanding, or a deeper mismatch between the use case and the chosen approach. Feedback is what allows a system to become more governable through use instead of becoming more opaque. Controls complete the picture by putting firm boundaries around what the system can do and how it is allowed to influence work. Some controls are technical, such as limiting system access, restricting which data sources may be used, preventing certain categories of outputs, preserving logs, or forcing review before actions can be finalized. Other controls are procedural, such as requiring second-level approval for sensitive cases, limiting the use case to a narrow population during a pilot, or setting rules for when the system must be paused and investigated. The important design lesson is that controls should not be treated as an afterthought once the exciting parts of the build are complete. Controls shape behavior, and they often determine whether users experience the system as a helpful assistant, an unchecked authority, or a risky shortcut. Good control design gives the organization a practical way to prevent foreseeable misuse, reduce silent expansion of scope, and stop the system from becoming more influential than leaders originally intended. These controls work best when they connect directly to the system's purpose and risk profile rather than being generic. A drafting assistant used in a low-stakes setting may need lighter controls than a system that ranks applicants, triages health-related information, or helps determine who receives additional scrutiny. That does not mean one system deserves governance and another does not. It means the design should reflect the seriousness of the consequences attached to the output. If the output can shape a person's opportunities, safety, privacy, or access to important services, then the controls should be more visible, more deliberate, and more resistant to casual bypass. This may include stronger oversight points, narrower scope, more aggressive thresholding, more detailed logging, and clearer escalation paths. A mature organization does not apply the same strength of control everywhere. It applies the level of control that matches the real stakes of the use case, while still keeping even lower-risk systems within a framework of review and accountability. Documentation and traceability also need to be built into design, because the organization must be able to reconstruct how oversight, metrics, thresholds, feedback, and controls were meant to work and how they actually worked in practice. This means the system should preserve enough evidence to show what version was in use, what output was generated, what context surrounded it, whether a human accepted or overrode the result, which thresholds were triggered, and what feedback was later attached to the case. Without that traceability, leaders may know that something went wrong without being able to explain why. Worse, they may assume the model is the source of the problem when the real issue lies in workflow design, poor review staffing, weak controls, or a threshold that was set too loosely. Design that supports traceability makes improvement much more realistic because it gives the organization something better than guesswork. It creates an evidence trail that can support audits, incident review, retraining, workflow change, and better governance decisions over time. A simple example can help bring these ideas together. Imagine a college building an AI system to help staff triage incoming student support messages for urgency. If the team designs only for classification quality, the system may seem successful when it quickly ranks messages and reduces workload. But if the team also designs for oversight, it may require human review for messages involving self-harm, housing insecurity, or legal trouble, rather than allowing a score alone to drive action. If it designs for metrics, it may track not only overall triage speed, but also missed urgent cases, override rates, and the kinds of messages most likely to confuse the system. If it designs for thresholds, it may escalate uncertain or borderline cases instead of forcing them into a confident category. If it designs for feedback and controls, it may allow staff to mark outputs as misleading, restrict the system to its approved purpose, and pause the workflow when patterns suggest rising risk. The safer system is not safer by accident. It is safer because the design made room for people, evidence, and restraint. Several common mistakes become easier to see once you understand this design philosophy. One mistake is assuming that human oversight exists because a person technically touches the workflow, even though that person has no real visibility or authority. Another is choosing metrics that are easy to report but too shallow to reveal whether the system is creating operational or fairness problems. A third is refusing to set thresholds because leaders want flexibility, even though the absence of thresholds usually means the organization has no clear point for escalation. A fourth is collecting feedback casually without structuring it in a way that can guide improvement. A fifth is relying on vague policy language about responsible use, while failing to build controls into the actual product and process. These mistakes are common because they let organizations move quickly, but speed without structure often produces a system that is difficult to govern once real users, real pressure, and real consequences enter the picture. By the time you finish this topic, the main lesson should feel direct and practical. Human oversight, metrics, thresholds, feedback, and controls are not features to tack on after a system proves itself. They are part of what determines whether the system can ever prove itself responsibly in the first place. Oversight keeps judgment alive. Metrics make performance and risk visible. Thresholds tell people when to slow down or escalate. Feedback allows learning instead of repetition. Controls keep the system within boundaries the organization can actually defend. When these elements are built into design from the beginning, the organization has a much stronger chance of creating an AI system that remains understandable, correctable, and trustworthy under real operating conditions. That is the heart of this episode. Good governance is not only about what the model can produce. It is about how the whole system is designed so that people can supervise it, measure it, challenge it, and keep it aligned with the purpose it was meant to serve.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.